Okay, in this last section of chapter 6, we're going to focus on the most used continuous distribution, which is the normal distribution. So right here I have a grand picture of the empirical rule. I should zoom out so in case you want to take a snip. If you haven't seen it before or haven't realized, we use it all the time before. Here it is again. The empirical rule is based on the probability of something happening, and again it's the area under the curve. So now this might make more sense. Let's just get into it here. The normal distribution is actually a family of distributions. So that's why we can sometimes standardize them. We can get their z-score. We can do that because it's a family of distributions. So there's a function that you can use, and this looks so bad. We're going to do, so this is kind of the function that we were using for the exponential distribution with the e to the negative lambda. But now there's some more. But we're not really going to use this formula. Just know that it is defined by a formula where mu is the mean and sigma is the standard deviation. The expected value is mu, and we actually have formulas for these in a different section. Okay, so empirical rule, blah, blah, blah. Now there's a very strong connection between the size of the sample and the distribution. As you get bigger, your sample gets larger and larger and larger, the more normally distributed that you will be, the more approximately normal you can say that we are. Here's a couple of graphs so you can see. Here's a flatter one and here's a taller one. So this one has a higher mean, a higher percentage of people closer to the mean, and then as you go out it gets smaller, but this one is more evenly distributed, more standardized. So we can have different shapes of these graphs. Let's just go ahead and get into this. We're going to start off with the standard graph. So we're starting off with the z-scores instead of x values like we were in the other ones. And then maybe we'll get into some of that later. Oh, I forgot one thing. Remember up here that these are the population letters. If you're looking for sample, that's x bar, s squared, and s. So it's population. Now we get to finally use all of those vocabulary words that we learned earlier. Okay, so some important things. These shapes are symmetrical. So what's happening on the left side is happening on the right side of the mean. The area under the curve is equal to 1, and they are usually bell-shaped. Now what's also cool here is that the mean is the median, is the mode. So it doesn't matter what central tendency you use, or measures to find the center, rather, that you use, because they're all the same. Again, though, if you're looking for the probability of a certain number, it's 0. So the probability of a single piece of information is 0, just like in our uniform, because this is a continuous. Now, sometimes I'll be talking about this and I'll say things like right-tailed, left-tailed. That's because we can look for the number of people that fall within this small area and use that to make predictions about the larger population and closer to the average. This side is the left tail and this side is the right tail. Sometimes we have an equal to, which means you'll have a two-tailed test or two-tail information, and sometimes we have a greater than or less than, and that is your left or your right tail. And we'll get into that while we're during these problems. So assume that a certain variable can be represented by a standard normal distribution determine the graph and value of P of z is less than or equal to negative 1.65 and P of z is greater than 1.65. So what we're going to do here is I'm going to draw you a picture so you can see. I should have brought my graphs. I'm really bad at drawing this bell curve. So we know that the mean is here. We're going to cut it off at negative 1.65. And remember, that's just a distance from the mean. So 1.65 plus or minus the mean is this location here. Now, if we remember, actually, you know what? I'll tell you that in a second. So PZ is less than or equal to negative 1.65. What I'm going to do, I'm going to do it in the calculator. Okay, so this is, we're going to go statistics, distribution, and we're going to do a normal CDF, cumulative distribution function, because this is going to tell us how much is underneath the area of the curve from the beginning to negative 1.65. The lower bound, leave it at negative infinity. That's what this is kind of representing. The upper bound is where you want it to stop, negative 1.65. Leave the 0 and 1. This is standard normal. If for some other reason they give you a different mean and standard deviation, you would change it. But this problem did say it's representing a standard normal distribution. Okay, so the normal CDF of this situation is 0.0494, which makes it approximately 4.9%. Okay, interesting. What about the probability that z is greater than or equal to 1.65? Well, I can run that in the calculator, and you know what? I might just do that just so you can see. I'm going to do menu, statistics, distribution, normal CDF, cumulative distribution, from negative infinity to positive 1.65, and don't change those numbers. You'll notice that it's 0.95. Interesting. Now that is, whenever it gives us a number, it's always giving us the shaded region on the left side. So the first number it gave us is about 4.9%. And then the next number it gave us, it was this value here. Let me see if I can get another marker to tell us that this is 95%. So when you're doing these, make sure you're being careful. It's always going to give you the left side area. It's not going to give you the area that you want on the right side, unless you change the calculator to do that 1.65 to positive infinity. So keep in mind that this is, to answer this question, it is 0.095 or 95%. Oh, it's not, because it wants to be, P is, oh, I just wrote it wrong. Goodness gracious. Now, what's cool is that because it's symmetrical and they're both 1.65 away, I could have skipped doing that second part and said that this part is also 0.49% or 5%. Now, another cool way, actually, let me just tell you, memorize this number. This z-score pops up all the time, especially in the section that we're about to do, the next chapter, chapter 7. Where we're doing confidence intervals, we'll use 1.65 a lot because it's 95% of the data, right? Or 5% tails. So when we're talking about that in chapter 10, this is what you should have got, because we have an alpha 5%. That's what it's talking about here, is this area under this curve. But again, we use 1.65 a lot to do that 5%. Now, assume that a certain variable can be represented by a standard normal distribution. Determine the graph and graph the value of probability that z is greater than negative 0.65. So 0 is here with mu, and then the probability that it's greater than negative 0.67, we're just going to estimate that it's there. So we want this side on the left tail. We have a left-tailed test here. Oops, sorry. You know what? Let me do something. Okay, I went ahead and found a simulator for the 84 so I can show you this. And there's a website at the top. I just typed in TI-84 simulator and it took me to ti84calc.com. And you can use this like a normal calculator. So I'm going to go ahead and work out this problem, or I'm going to try. So second distribution is what we're looking for. Looks like it is hiding under the vars button. So second variable is really what you're looking for. And under distribution, again, don't use the PDF. We're going to use the CDF. So we want number 2. And if I'm correct, you can keep this lower of negative 1e99, or you can change it to 0. It shouldn't make much of a difference. And hit enter, and then your upper, in this case, is negative 0.67. And again, don't change your mean and your standard deviation. Just keep hitting enter until you have this, and hit enter one more time. And of course, let's see what happened. It doesn't like my negative 0.6. Oh, because I used a minus sign. I'm a mess. I just changed that to the negative down here at the bottom, and I'm going to hit enter again. There we go. So notice that I didn't answer the question correctly yet. I found the area below negative 0.67. If we go look at my problem again, I want z is greater than negative 0.67. So I found this side. Again, that's because it already prompts us to do the negative infinity to this. So to get my answer, I could go back to the calculator and put negative 0.67 to positive infinity, or because we know that the area under the curve is 1, we could do that this is equal to 1 minus the probability that z is greater than negative 0.67, which gives us 1 minus our number of 0.251, which is approximately 75-ish%, or 0.749. Okay, so you could do it both ways. You could use whatever calculator. I'm pretty sure you can also put it in Excel, and I can make a video of that if you'd like me to do that again, like I did in your previous chapters. You know, I'm going to call that video for now, but I'm going to come back in my next video. I have a bunch more examples. So if you need some more help, watch the next video, and I'll do another 14 minutes of examples for you on the normal distribution. And in these examples, they have everything from finding the mean, the standard deviation, finding the z-score, finding the percentile, if I remember correctly. So I'll put all of that in the next video.